All right, so today we're diving deeper into Django. Part one of the morning lecture before the work time will be looking more at validators, which we sort of got a very lightweight introduction to yesterday when we talked about model fields. We'll see how to use all of Django's built-in validators, both the ones that are built into various fields, like the email fields that we saw yesterday that does some validation. And Django also has some built-in validation functions. We're going to learn how to make our own custom validators, our own validator functions, and we're going to write a couple Django tests. And you all got a little bit of a preview of that with yesterday's assignments. Like all of our graded assessments, the Django assessment is going to have tests. So we'll write some of those today and talk about them. Then you all will get a little bit of hands-on time, and part two of the lecture, we'll be looking at this pretty cool framework called Django Rest Framework that we're going to be using throughout the course and how it helps make our lives easier. And we're going to learn about serializers, which is about, now that I have these models, it'd be nice to turn them into JSON because eventually we're going to want to send them over the internet to the browser, and how Django Rest Serializer can help us with that process. Does anyone have any questions about the agenda for today? Okay, awesome. And just to warm us up, I've started building a Django project, but I haven't built out yet the Pokemon model that we did yesterday, and I think that could be a good warm-up. So we can see over here, there's this backend directory, and I made, just like yesterday, there's Pokédex project, there's Pokemon app. I have gone ahead and I've added Pokemon app to installed apps, and I've created a database for it. But there's nothing in here yet. And as you can see over here, I have a virtual environment in my project directory. I run the Django server, it runs on port 8000. And we're not doing a lot with this yet, but this is my sanity check to make sure I don't have any typos in my code. And over here, I see that it's up and running. And in fact, every time I refresh, we see that the Django server is handling this GET request. So the next step, I think, is let's build out that model from yesterday that we had in the Pokemon app, right? So we go here to models PY, and this is a class Pokemon. And can someone maybe remind me, what does this class have to inherit from? Daniel, yes, sir.
It has to inherit models.model.
Yeah, exactly. Thank you. Django has a built-in model class, right? And we have to inherit and use that to build our Pokemon class, or rather our Pokemon model. And now let's go ahead, let's add just those same fields that we did yesterday. I'm just going to add name. And this is going to be a char field. We'll give it a max length of 255. We won't give it a default name. Our Pokemon is going to have a level. This is going to be an integer field. This is going to have a default value. All our Pokemons will start at level 1. And by the time we got to the end of our lesson yesterday, I believe we also had some information about if our Pokemon had been caught and date created and stuff like that. So let's throw that stuff in as well. Anyone maybe want to remind me how we add those other two fields to the model, date encountered, date captured? Murad, yes, sir.
Yeah, manage the Python, manage the Python, and make migration paths.
We will do that eventually, but right now we're just working on adding the fields to the model code.
Okay.
And I can go ahead and do that by again, we're going to use these different model fields that Django gives us, and I'm just going to use model date field. For simplicity, I'm going to give this Pokemon a default of Pokemons will all have a default encounter date of 2008. And Murad, we absolutely are going to get there in a minute. We are going to have to run some of these migrations. For date captured, again, I'm just going to give my Pokemon a default date for this. And you could argue maybe by default this should be none, but it's not the end of the world because we're also going to have a Boolean that tracks this information. And actually, instead of a date field, I want a date time field, so I get a timestamp here. And let me make sure I am typing this right. Default is time zone. Like that. And I have this red squiggly here because time zone is a Django library that I have to import from Django utils. And in fact, I'm getting a lot of red squigglies here because I haven't set my default Python interpreter. And I'm going to do that right now. As always, I find this process a little annoying because I have to grab the path, and then inside here, we're going into the virtual environment. And I believe it's like bin/python 3. Let's double check the env bin, and inside there I see Python 3.12. So I want my virtual environment path /bin/python 3.12. And let me try that one more time. And if we can't get this sorted, I'll just move on. I'll just move on and I'll just deal with the red squigglies today. My apologies, folks. So we have date encountered, we have date captured. We probably want a description for our Pokemon, which is going to be more straightforward. And again, we can use a model field, right? A text field, models.text field. We can give it a default value of unknown. And it would help if I made that a string. In our Pokemon also, we want to know if it's captured or not, and that's going to be a Boolean field. And by default, our Pokemon will not be captured. And then we made some methods yesterday as well, right? We had a dunder string method, so I could see some information about my Pokemon. And I'm going to do a little bit of copying pasting here, I think, in the interest of time. And can someone remind me, what were the other methods that we wrote yesterday for our Pokemon? And what did they do? Right, we wrote 2 methods on this Pokemon class. Daniel, yes, sir.
We had one that said level up and one that said, I believe it food?
I might have added that when we were exploring stuff and I was adding student stuff, but I think the other one was about changing if the Pokemon was captured or not. And Daniel, how did this level up method work?
I believe we incremented it, the level each time every time this instance was called, self level up plus equals 1. And then after that, we have to actually save it in order for it to save in the database.
Yeah, exactly. And what does that self.save do, by the way?
I believe that self.save, it saves the instance of the Pokemon class, and it saves it to the database and updates it.
Exactly. Right. We change this, and then this actually saves our updated Pokemon model instance to the database. Also, just as a quick sanity check, folks, you're not seeing my Zoom grid on the screen share, are you? Okay, good. Perfect. And Garrett, what was the other method that we wrote yesterday in class?
think it was to release the Pokemon.
Close. It was to capture or release. We were calling it change clock status. And Garrett, can you maybe tell me in sort of pseudocode form, how do I change the status of if a Pokemon is captured or not?
Since captured as a Boolean field, we're pretty much just gonna do the opposite whenever this function's called.
Yeah, exactly. And then what's the other thing I need to do here in this method?
Save it.
Yeah, exactly. And now we should have a Pokemon model with pretty much everything we had yesterday. Let's go ahead and, like Morad was saying earlier, let's run our migrations. Let's see if I had any typos, if this works. Let me make sure I'm in the right spot. Let me navigate outside of my virtual environment directory. And it looks like I have probably a typo here. I see models.models. Right, so let's just hop over here, and right here I can see I have this twice where it shouldn't be, and in fact I kind of see the color formatting indicates that's an issue. And let's try that command again. And now we've created a migration, right? And over here we have our migration file. We don't need to go through this in depth. We kind of talked through what it does yesterday, but this has our Pokemon model and all of the fields we created for it. And can someone, Tim, can you explain to me, we've created the migration, right? I ran the make migration command, but what does, Tim, what does the actual migrate command do? And you can, if you're not sure, you can phone a friend.
Yeah, sorry, phoning a friend here.
Who are you phoning?
Whoever wants to go.
You got to pick someone. That's the rule.
Okay. Well, we got Momo then, or he doesn't want to.
Yeah, it's okay. Yeah, it send this data, update the data in the database.
Yeah, exactly. And Tim, thank you for letting me put you on the spot there. And Murad, thank you for picking up the phone call. Right? If I go into pSQL, we still don't have anything in our database. But now, if I run migrate and we go back to pSQL, we should, unless I'm looking at the wrong database name. Brandon, yes, sir.
The way I see it is make migration is like a git add and commit, and then the git pushes the migrate. It's similar to git.
Yes.
It's just like how I think about it.
Yeah, you're
Thank you.
absolutely
That was
correct.
very helpful.
Yeah, that's a great way to describe it. So I did make one mistake, folks, when setting up my Django. And I can tell that I made this mistake because I'm looking at my database in Postgres and I'm not seeing any of the changes I should see. If we look here in settings PY, I totally forgot. I need to update the Django configuration settings for what database to use. Right? By default, it uses this other database called SQLite 3. That's actually pretty cool. And I believe we need to change that to PostgreSQL. And we need to change the name of this to Pokédex DB. So if you're working on Django and you're not seeing your migrations applied, this is a good thing to double check and make sure that we have it what it should be. And in fact, I'm just going to quickly double check to make sure that I have this correct. And then fingers crossed, we should be good to go. And we should, in fact, have our migrations applied to the database. So let me hop over here back to the console and let me run Python manage.py migrate. And I forgot, I need to install psychopg2 or psychopg3. Can anyone remind me what is psychopg? Why is it breaking Django that I don't have it installed? Someone maybe who hasn't answered a question yet today. Morad, I appreciate you raising your hand, but I want to make sure. Yeah, Eric.
It's the interpreter that allows Django to talk to your database.
Yeah, exactly. And very specifically, Postgres. Without psychopg, Django and Postgres aren't going to be able to talk to each other. And before I forget, I'm just going to pipe the output of the pip freeze command to get all of these dependencies that we've installed into our virtual environment into our requirements.txt file. And now let's try Python manage.py migrate. And good news, right? We see all of these being applied. And Kyle, can you maybe remind me, like, I'm seeing all of these migrations that have nothing to do with Pokemon. What are they and where are they coming from? And if you're not sure, you can phone a friend. Or maybe Chris.
Yeah, I'm a phone a friend. Brendan, yo.
Sorry, what was the question
Sounds
again?
good. Yeah, I see all these migrations, but all I did was create a Pokemon model. Where are these coming from?
Yeah, I'm actually not sure.
I'm giving you all a big hint right here.
Is it coming from Django itself? Like
Yeah,
yeah.
exactly. All of these Django apps, all of this Django code, just like the code that we're writing, that's part of, you can think of it as the Django standard library, apps that are installed by default. They need to do stuff to the database too. They have their own migrations. And so every time you start a Django project or you clone one, you need to run this migrate command just to apply the built-in Django migrations, if nothing else. And now if I hop over here, we have a whole bunch of tables, which is exactly what we want. Right, and now I have my Pokemon. Let me go ahead and run the Django shell. I installed this little helper tool, Shell Plus, that I'll share a link with how to use later that imports all this stuff automatically for us. So I should have my Pokemon class right here, right? And now we can go ahead and we can create some Pokemon, and we'll make Pikachu Pokemon. The name obviously is Pikachu, and the level will be 12. And Pikachu is yet to be caught, right? I don't see Pikachu in my database. If I do select star from Pokemon at Pokemon, what's the command I have to run, Joseph, to actually get Pikachu saved to the database?
Pikachu.save.
Yeah, exactly. So, and here I realize we've been doing some review. Just to throw something new into the mix, there's another way to create a Pokemon. I'm going to do it right now as I create Bulbasaur. If I do, instead of the way we just made Pikachu, Pokemon object.create, this should, unless I'm getting something wrong, actually save Bulbasaur to the database for us. And let's see what I did wrong here, because I feel like that should have done it. If I had to guess, I think object needs to be plural, objects. So Pokemon objects create. If I go here to select star from Pokemon, I see Bulbasaur, right? And one moment, Eric. So just to recap, there's two ways I can create a model. One is I can call our class constructor the way that we're used to, like this right here. But then I have to manually run the save operation. The other way I can do it is if I do .objects.create on my model and then use this method, it will save it to the database for me. Eric, yes, sir.
So this is actually looking a little bit ahead into what we're going to cover today, I believe, but I was watching the Whiskey video on this. And at the time, Francisco was saying maybe don't do that because it kind of bypasses your validators and your full clean method if you do the objects.create.
Yeah, that is a good point, and we are going to get there later. You're absolutely correct. Like when we start learning about how validation works, we'll see that this is a bit of a double-edged sword. Totally. I've got some Pokemon in my database, right? And let me open up another terminal tab for myself here so I can do stuff, and let me activate the virtual environment. And let's see. Oh, I'm just kind of running down the list here. Polly, can you maybe remind me? I want to get this data out of my database and I want to save it. And I want to save it like maybe in some sort of text file or JSON file so that if I have to drop and rebuild the database, I have my Pokemon data. How can we do that? What's the command to do that for us?
It's
And if you're not sure, you can phone a friend.
is this when we use the git ignore? Is that what you're asking about?
Close, not quite. What I'm thinking about is here in the Pokemon app, I want to make a directory, and we're going to call it fixtures. Gary, yes, sir.
I was going to say the dump data. Was that what you're looking for dropping it?
Yeah, exactly. And I don't remember. And Polly, I apologize if that question was a little too vaguely worded. And I don't remember that command exactly. I'm going to use Control-R on the command line to just search and find the command that I ran yesterday. And we see it right here. Python manage py dump data, the name of the Django app, the name of the model, some indentation so that we can read it more nicely. The arrow that points to the file that we then want to pipe this data to, which is now that I've created that fixtures directory, I just named a file Pokemon data to JSON, and we'll just change that to Pokemon data.json. And so now here in the fixture file, we can see our dump from the database, right? And we can see how Django stores this, the model name, the primary key, and the fields. I'm not going to go through the process of dropping and rebuilding the database now, but now we have that information there, right? So now hopefully we're kind of warmed up, our brains and back in Django mode, and we can start talking a bit about validators and how they relate to models and just creating models. And let me just pause and check in and see if folks have any questions or things that it might be good for us to briefly touch on before we move forward. Okay, cool. Validators. So we've made a model. There's kind of these like 4 steps to making a model, right? We need to create the model itself. We're going to want to like add some validation to the fields of that model to make sure that the data we're putting in is good. We're going to need to create the migration and apply it. And then we're going to need to test that model. And that's sort of the flow that we're going to be looking through this morning. So we've learned how to create a model. We've kind of done some review of it. So we're kind of all refreshed and we have our heads in Django land. There's a couple things that you want to be thinking about as you build Django apps and start making more and more design decisions. What does this model represent? How does it end up in my database? How do the fields get turned into columns? What fields does the model need to work the way I want it to? One piece of this puzzle is validation. We saw a little bit of this yesterday. Remember the email field that we briefly took a look at actually had a couple validation rules that it applies. But we're going to see Django offers us a lot of tools, a lot of functions to check if data is valid or not before that data gets saved, right? Because I don't want to be able to put in like an integer for Pikachu's name, or I don't want to be able to put in for Pikachu's name a string that's 10,000 characters long, right? That could potentially, if someone malicious was doing that a lot, that could eat up a ton of space and maybe crash our database because we run out of space or something. Though the database engine itself might jump in at that point. But there's a lot of different reasons, both for good application design, for data integrity, and for security, that we want to validate our data before we actually save it to the database. So adding validation to fields is really important. So we'll hop back to this slide deck later. Let's actually start doing a little bit of validation. And I think what I'm going to do is let's just as a bit of a preview to kind of see where we're going. A validator is a function, right? This is just a fancy word for function that takes a value and it raises a validation error. Just like we've seen, Python has built-in error classes. Django has a built-in error class named validation error. If it doesn't meet some sort of rule. And validators are great because we can reuse that logic between different kinds of fields. And we're going to write our own validator in a little bit. But again, just to get a little bit of a preview, we can see that, and let's see if the, there we go. So they're importing this validation error class, they're importing some other stuff, they're checking if a value is not divisible by 2. If it's not divisible by 2, it raises an error. And this is the fundamental job of a validation function, is if the value doesn't meet the rule, we raise the validation error. And then over here in this model, we have this argument validators that takes a list, and we pass in those functions as arguments. And so let's add some of our own validation now to our Pokemon. And in fact, I will just pull this code up here as a reference as we start to do this. And I apologize, I jumped around a little bit. So let's start with some of the built-in Django validators. And in fact, there's a list, and just to show you guys, somewhere in here is the list, here we go, of all the built-in validators. And you can see there's a lot, right? There's a regex validator, there's an email validator, there's a URL validator, there's an awful lot of validators. And we'll take a bit more of a look at them in a minute, but we're gonna add some built-in validators to our Pokemon model. So let's close this out. We're not using settings PY. Let's close that as well. I'm going to import validators. And again, I apologize about this red squiggly. This is killing me. I thought I had this sorted yesterday. Let's try this. One more time. There we go. Sorry about that. So in fact, if I right click here and do go to definition, now that I've fixed my Python interpreter class, we can see, and this is way deep inside the virtual environment directory, the actual core Django code for all the different validators. And we can see all these different classes just to sort of give a little bit of a preview. And we don't have to kind of go in depth, but we can see there's an awful lot of stuff, right? And in fact, if I use the outline view, we can look at all the different validation classes. So there's a lot of cool stuff, validating IP addresses, min value validator, step value validator, decimal validator. There's a lot of very, very useful built-in validation functions. And I'm aliasing it as V just so that life is easier as I'm typing stuff. So I think a good starting point is the Pokemon level, right? Like I don't want level -50 for my Pokemon, and I don't want level 10 billion. So we're going to pass in a list of validator functions. And we're going to pass in the min value validator. And so the way we have to use these built-in validators is I do have to call it in here, and this returns the actual validation function that gets used. And I'm passing in the minimum valid value. Right, so now our Pokemon level has to be at least 1, and it can't be greater than 100. And I just want to check in and see if folks have any questions about how to implement this and if everyone's feeling good about this.
Can you just show again one more time where you went to go see all of those different validator functions?
In the documentation of the source code.
Source code?
Yeah, absolutely. So VS Code, if you just right click on pretty much anything and you go to definition, VS Code will go to whatever file where this thing is defined, right? Like this is the definition for the Pokemon model. And this, you can see the path here. It's in the virtual environment directory where Django gets installed. You can see that the way the Python virtual environment works is Django actually gets installed under the version of Python that we're using, right? So then vlib Python 3.12, site packages, Django core, and then this file validators py. The Django docs on the built-in validators will be a better reference, but this is kind of cool to see.
Thank you.
Yeah, absolutely. That go to definition is super useful in our own code, by the way. And I think, yeah, F12 is the hotkey for it. As your code base gets bigger, that is one of your best friends. So let's add a little more validation. Let's maybe validate our Pokemon description. Let's not let this be a text field of infinite length. Let's do v min length validator and say that the description has to be at least 7 characters long, but it can't be more than 150 characters long. Right, and I think that that's a pretty good validation step right here. The date validation gets a little trickier. I'm not going to worry about it too much for learning purposes, and we already have date fields set. Boolean, there's not a lot to validate here. It's true or false. Both are valid values, right? And so now we've added validation. Let's go ahead and see how this works in action. And someone was talking about this before and the different steps of the validation process. And let me go to my shell and let me go ahead and quit this and reopen it just to make sure that I don't have anything that there's not anything that like didn't get updated in here. So let me get all the Pokemon. I think that's always a good starting point. Right, and we've got in there Pikachu, we've got in there Charmander. All of those things are valid. We might come back to that later. Or Pikachu and Bulbasaur. Let's make a new Pokemon, Charmander. And let's go ahead and just create them, and the name will be Charmander, and the description will be food, right? So this should be a bad description, right? It's not at least 7 characters long. But as we can see at this point, in just creating the Pokemon, my validation logic actually hasn't gotten applied, right? So in Django, there's actually some explicit steps we have to run to apply these validation rules. If I save my Pokemon, the validation still didn't get applied, right? And in fact, if I look, I see indeed Charmander is there in the database. We actually have to explicitly call our validation logic. And we use a special Django method called full clean to do that. The reason we have to do this is Django wants to give us control. This feels a little annoying, but once you get used to it, it's one line of code that you add in and you have helper functions, so you don't have to repeat yourself a ton. So Django has a bunch of validation stages that occur. And now we see when I run this full clean command, this validation process gets run. And let me actually pull up full clean in the Django docs because it is, I think, very useful to look at. And in fact, we'll go here to how validators are run. So there's a lot of logic for how validators work. We care about validation for objects. Django does this in 4 steps. It validates the model fields. And to do this, it runs a method, clean fields. So in fact, over here, I could do Charmander clean fields. And that throws my validation error. And let me maybe give us a little more room here. That's the first step that Django, so full clean does all 4 of these steps is where I'm going with this. I apologize, I should have led with that. And that's why we always want to use full clean. Django breaks down its validation into 4 separate steps to give us control, and because different kinds of validation are needed for different things. So this validates model fields, this validates the model as a whole. When we learn about adding validations for uniqueness constraints, like say for an email field, because that kind of impacts the database in a different way, there's a separate step for validating uniqueness. And then we might have constraints around model relationships or other things. So there's actually 4 separate methods that get run for validation. Full clean will run all of them. So full clean is our friend. That's the one that we want to use. And as we write more and more Django code, that's what we'll actually be doing in our code is we'll always be running full clean before we run save. There are very few cases where you want to actually run save without running full clean. And as Django says right here, full clean does not get called automatically when you run save. Right, so full clean is going to become a regular part of our process. And just to kind of recap here with Charmander, if I run full clean, right now we get this validation error. Let's change Charmander's description. Let's run full clean again. It passes. Let's save Charmander. And so, you know, if the first time we create a model, it's doing a Postgres insert operation, I believe now the save operation should be doing an update. Right, if we think about how that gets translated into SQL, there's insert and there's update. Well, this row already exists. So under the hood, that save method is running update. And here we can see now Charmander's been updated and that works correctly. So, you know, as was pointed out earlier, and actually, what's another Pokemon? I need to, let's throw one more Pokemon into the mix that we can talk about. I'm Pokemon ignorant.
Squirtle.
Squirtle. Yes, I do remember Squirtle. Squirtle is great. Let's make Squirtle. And let's do Pokemon.objects.create. And the name is going to be Squirtle. And the level is going to be -50, right? So this is invalid. But like someone was mentioning earlier, this objects.create doesn't run the validation automatically. In fact, Squirtle is now in the database. So you'll see sometimes in our code and in our tutorials and in the lessons, Pokemon objects create. It's a nice shorthand because what it does is it saves the thing to the database right away, but it still doesn't apply validation, right? If I do Squirtle full clean, we get a validation error. And note that here we have a really nice message about the validation error. Ensure this value is greater than or equal to 1. For level, ensure it has at least 7 characters. Oh, it has 6. I guess unknown. I guess our default setting is actually fails our own validation error now. 1, 2, 3, 4, 5, 6. Yep. So we have to make a couple updates here. This does raise a good point about the limitations of Django validation, and I'll talk about that in just a moment. Let's fix Squirtle's level. And I don't know, 10. Okay, so Squirtle still has a problem with the description, right? The default description unknown is 6 characters, but we've set the minimum the length of it to 7. But guess what? All of my Pokemon also have this problem. Right? Pikachu has that problem. The other Pokemon has that problem. So what we see here is that the Django validation logic only gets applied, you know, in Django, in our Python code, when the data is on the way in. Once the data gets into Postgres, these validators are not being applied. Postgres doesn't know they exist. Right? If I hop back kind of to the TL draw from yesterday, and we navigate over here to our okay, not great diagram. But if we look at, you know, moving data into Postgres, once it's in there, Django doesn't touch it. Right? So it's perfectly possible, like we did just now, to add a validation rule, but already have data in the database that violates that validation. So that's just something to be aware of. Validators are really for data coming on the way in, right? And the way to address this issue, you know, would be, if we want to, is I would just have to go through all of my existing data and update it. And obviously we should change this to be something else that is a valid default setting. But again, does changing this default affect any of our existing data in Postgres? No. And does changing that default, it will maybe create a new migration, but that still won't affect the existing data. And let's get rid of that typo. Right, and we see that there's a change to the field description and the level. we see that that's been applied, but if I go in here, my previous data still has the old value, right? So this is the limitations of Django validation. It's very powerful and it's very useful, but it can't solve everything. And this is why it's worth thinking through a bit, like your data modeling up front, and thinking through, you know, when you're changing validation, do I have existing data that I have to modify? So this is a good stopping point. I just want to pause and check in and see if folks have any questions. Then in a minute, I think we'll write our own validation function, and maybe take a quick look at tests and take a short break and look at tests. So this is a good pause review point. How are people feeling? What's on people's minds? And let me check our questions channel as well. Erica, yes.
So how do you validate previous information easily without having to go one by one through the information in the database that's already established?
Yeah, that's a good question. Honestly, validators are not for information that's already in the database. They're for when information's going into Django for the first time before it hits the database. If you need to modify existing data in the database, you would just write some sort of script.
Okay.
Yeah, good question. And answer is it's not validator's job. So, you know, if this was like a real work situation and we added these validation rules and I was the engineer who got this task or this issue or this ticket, you know, part of what I might have to do is look at the existing data, see if it meets the new rules, and if it doesn't, probably come up with what the new default should be, and maybe like write a script that we would run to modify the existing data. Yeah, great question. Earl John, yes, sir.
Would it involve dropping the fixture and then dump the data again with the new default?
Great question. So you're absolutely correct that the fixture data needs to be updated as well. And in fact, I didn't even think about that, right? If we have test data, let's hop over here to our fixture data. You're 100% right that this stuff needs to be modified. Now there's two scenarios here, right? One is we're developing, we don't have a live application with real users. I don't actually care about the data in my database. I can dump the whole database and rebuild it exactly like you're saying with this fixture file and the new updated default. Scenario two is this database has been deployed, the application's been running for 2 years, and we have 10,000 Pokemon in here. So obviously I don't want to dump the database, and I have to, the term migration doesn't just apply to the migration tool that we're learning about. It is often used for any sort of big change to a database, right? And so it's not quite a migration, but as part of this process, I might have to write a script and like modify the description of all existing Pokemon in the database. Does that help answer your question?
Yes, thank you.
Yeah, great question and great point about the fixtures, because I totally forgot about that. And I think, you know, what you all are starting to see is that there's a lot of moving parts and things to keep track of, right? The good news is it's relatively straightforward for us right now. And for all of you for developing, I think this is why fixtures are your friends. Don't put a ton of data in here so it's a huge pain to modify, just a little like this. And then Earl John, exactly like you were saying, hey, when we change the validators, let's maybe just update this or generate new fixtures, and then we can just drop the whole database and rebuild it. But yeah, like once you start dealing with real data, there's more complexities that come in and more things that have to be thought through for changes to the data model, which is a bit of a big deal, which is why Django gives us such fine-grained control. Daniel, yes, sir.
So I'm a little bit confused. So validators are descriptions of what needs to be changed, right? But it'll still go to the database, correct?
Validators are functions that validate if a value meets the rule. And in fact, we should write, I think, a validator, and that will help us see. And what you're saying is, hey, when I run save, that actually doesn't validate anything. It just saves it to the database. And you're 100% correct. So, and in fact, how do we have to modify these two methods to apply our validation rules before we save to the database using these model methods? Daniel, yes, sir.
Oh, I meant to raise my hand down, my bad. I actually don't know.
Oh, Eric.
You just add full clean before the save.
Yeah, exactly. So this is an extra line of code. We do have to add it manually. For better or worse, Django has made this design decision because sometimes there are situations like maybe if we're initializing a whole bunch of things into a database for the first time, we just want to save it. So when you're writing Python code, we have to add full clean here before we do save. And in fact, we can test this. Let's see, our max level value is 100. Right, so let me exit this and pop back in. And let me grab Pikachu. I'm going to do Pokemon objects all sub-0. And that should give me Pikachu. Yep, and let's go ahead and clear this. And Pikachu's current level, I believe, should be 12. So let's set Pikachu's level to 99. Let's do Pikachu dot full clean. Oh, and this is the description. All right, fine. Let's update Pikachu's description. Now let's run full clean. It passes. Let's save our Pikachu. Now let's use level up, which now should have full clean, right? So it should bump Pikachu up to level 100, run the full clean to validate and save. And let's do this a couple times and see if we can get it to force a validation error. So far, so good. Let's try it one more time. And now we get that validation error, right? And if I look at Pikachu's level, well, this actually points out an issue in my code, right? This hasn't been saved to the database. If I look at Pikachu, their level's still 100 because the full clean stopped the save. But here in my code, the level actually did get bumped up, right? So I have a couple decisions about how I want to handle this. Maybe I want to like calculate the new level and run. We probably don't want to do that. We probably just need to handle the error. A level up is how we would need to do it in the code. But we can see here that full clean does its job of stopping the save from occurring because it raises the error. So when you're writing code, this is what you'll want to be doing is full clean and then save. And validators are just functions that check the values that we're setting fields to. And the validators get run when we run full clean. And I think if let's write our own validator and then I think that'll be a good time for a break. Earl John, yes, sir.
Would it make more sense if before you run the full before you level up by 1, you run the full clean first and then level up 1?
Yeah, I was just thinking about that. The issue is full clean looks at the instance of the object. It's going to look at self.level. So if self.level isn't changed, then full clean will pass just fine. What we would really need to do is something like this. I'm not remembering how to properly write a Python try catch block off the top of my head, so I apologize. But self level minus equals. I don't even know necessarily if we'd want to do this, because it really depends on like the code that's calling level up to handle the error. So even doing this might not necessarily be good, but the intent here would be like if validation error is raised, don't change level, right? To kind of pop it back. But again, none of this actually gets saved to the database. Erica, yes.
So this sounds a lot like the PSQL conditions, like the constraints. Would it be a good practice to double down and actually add the constraints to the PSQL database too, like to the schema?
That's a good question. The answer is it depends. The advantage of validations is changing Django and Python code is easy. The challenge with the actual data model in Postgres is, again, think about we have like 10,000 Pokemon in the database. We've added a constraint, the level has to be 100, and now Nintendo decides that the level can be higher. On paper, that should be easy. In practice, it may not be. So what you often see is devs will try to keep at like the lowest level, which is the actual Postgres rules and constraint, to be more conservative in how many constraints or rules they apply, and sort of push validation rules up to higher levels. But the right answer really kind of depends on the data model and the use case. Does that help? I know that was a bit of a longer answer, but does that help answer your question a bit?
Makes sense, yeah.
Cool, awesome. Yeah, in theory, you're absolutely right. In practice, again, if it's like a large database with a lot of stuff in production, changing constraints or like changing fields, it can be tough to kind of predict. There's just so many moving parts. So what you'll see is people will try to keep like that lowest level at the SQL a bit more conservative and have this in the code. Also, from the perspective of like readability and programmers understanding how the application works, in general, it's a bit easier to kind of see what the rules are if they're in code, as opposed to sort of like database rules and constraints. But constraints will be used as well. The goal with constraints at the end of the day is data integrity is the most important thing, right? And the Pokemon level is a little bit more about domain, like not allowing a negative value might be a useful constraint to add to the database level for Pokemon level, because that's less likely, but even there, I don't know. So this is a little weird, right? But not necessarily bad, because it raises an error, and then it's the responsibility of whatever code calls this function to handle that error. So we don't necessarily want our level up method to have to worry about dealing with this. The job of this is to run validation. If it's not valid, don't save it. If it's valid, save it. And throw an error. And then it's the job of whatever code calls this method to deal with that error. All right, let's write our own validator function and let's take a break. And I think you all will be pleasantly surprised how straightforward writing a validator function is. So I'm going to go ahead and just create a file named validator.py here in our app. And it's just a nice place to kind of put everything. We're going to need to import this validation error class that I keep talking about. And we're going to use some regex. So we're going to import the Python standard regex method. And we are going to write a validator to validate a Pokemon name. Right, and a validator function takes a value, and we'll just call that name. That's what we're validating. We're going to want to give some sort of error message. So we'll just say improper name format. This regex I am totally copying and pasting. Basically, the regex is to make sure that the name only has letters in it, I believe. In our curriculum doc, we actually, in the comments of it, we kind of break down line by line what each part of the regex is doing. But in essence, we're checking that our string starts with a capital letter, and then checking the rest of it that it's a character A through Z, and not something else. Brandon, yes, sir.
If you need to test your regex, you can go to regexr.com and it just helps you write your regex. Because I know for the assignment, there's going to be other regexes you have to write.
I love it. And let's see, does this give us, oh yeah, this is a good one. Does this give us Python regex?
I think regex is global, so you can.
It is mostly global. Every now and then there's sort of like variations in syntax.
I tested it and it worked for mine, so.
It looks like in the top right corner, there's a drop down. Right now it's on JavaScript.
Oh, there we go. Thank you.
Can you post this in the resources?
Yeah, let me throw this in the Zoom chat. If someone can repost it, that would actually be awesome. Yeah, this is close enough with the JavaScript setting. I'm not sure what the PCRE server thing is. There are different regex engines, so that there can be flavors, though most of it is pretty common. But this is great because we
change the text. You can also just straight up change the text to like a name if you wanted to put the name in there.
Oh yeah, that is a great call. Pikachu, Charmander, or let's just try. Yeah, so this is.
Your bracket isn't closed.
I'm not even sure if I have an opening bracket. And this is where, to be honest, I'm a little rusty with regex. Oh, you mean this?
The first.
Oh, I see.
Yeah,
I see. Yeah, thank you so much. So, yeah, this is. What am I missing here where this is not giving us? It's not telling me that Pikachu with the lowercase p is bad. Or let's add like a 7.
I think you need a plus sign, and without the 7. So instead of the star, you need a plus sign.
Yeah. Okay. Yeah,
And
this
then
is where.
Take out the 7. Oh, okay. I don't know then.
No, it's all good. Honestly, this is an incredible tool. It can help design regexes. Just in fact, let's Python regex checker. Python. So there's like little syntax differences, and because regex is so dense, it's just hard for me to remember. And frankly, I don't even make the effort to remember regex. Like when I need to write one, I use Stack Overflow. But then I do always take the time to understand it and like very generously in the code document what it's doing. right? So this, I think, looks like what we want because we're seeing no match, match, right? And so this A through Z is checking the very first character, that it's a capital A through Z, and then we're checking that the rest of it is lowercase a through lowercase c. And I'll throw this one in the Zoom chat as well. And if someone could cross post that in Slack also, that would be awesome. Regex is great to dive into. I'm not gonna lie. And I do always like add pretty heavy documentation to a regex. Like if I find a regex on Stack Overflow, I'll include the link to the Stack Overflow in my comment, and I'll include a pretty in-depth explanation, which is what we have in the curriculum. In fact, for this, and just to show an example, like this is pretty good. So, and I encourage you all to make this your practice with regex, because unless you use regex all the time, I can guarantee that like a month from now, if you come back and look at this code, you're gonna be like, what the heck does that regex do? Plus for other programmers, it's very nice. So we wanna check if our name is good or not, and we're gonna use this regex matching. And it's going to return a Boolean. Right, and if it's good, we can just return the name. Not a big deal. Really, if it's bad, we want to raise our error. And so this is the message, and then I believe the validation error will also show these params. So like if there's data that we want to pass, we pass it as a dictionary here to show additional information along with the error message. So this is the important step here, raising the error. And as you can see, like we can have anything we want really inside of this validation logic. And now to use it, it's pretty straightforward. We import validate name, and now we can apply it to our Pokemon name. And I think I probably will have to like exit and restart the shell to make sure that I'm grabbing the updated validator. And it looks like, in fact, I made an error. And I might need just dot validator. And there we go. Oh, and it looks like I'm grabbing Bulbasaur instead of Pikachu, which is okay. I don't think objects all necessarily is guaranteed to give them back in the same order every time. As you guys have probably been noticing, sometimes like different Pokemon seem to come back first. So we'll just do Bulbasaur equals Pikachu just so the names are consistent. And if we look at Bulbasaur's name, right, looks good. Let's change his name to something that's not going to be good. With the lowercase b instead of a capital letter, and run full clean and watch the validation fail. And we see here that params argument from our validator and our description, and that Django has added some nice stuff in there as well. So that's writing your own validators. I apologize, we haven't gotten to tests, and I do want to show that, but we have been running for a while. Why don't we take a 7-minute break, and then we can look at tests, and then you all can get like 30 minutes of hands-on time. Does that sound good to folks? Okay, awesome. Folks, thank you very much. Let's take 7. So we're going to come back here at on the 20 at 10:20 Central. And we'll take a look at tests, which are going to be pretty friendly, and you already have seen a bit. And then you all can get a bit of hands-on time before we start diving deeper and looking at serializers. So thank you very much, folks, and I'll see everyone in 7 minutes. All right, so we have actually covered quite a lot of ground. We did a bit of general review from yesterday to kind of get ourselves warmed up. We've kind of talked through the process for models. We've really seen validators in depth now, built in and our own, and most critically, how Django applies validators, right? And the big takeaway here is we need to manually apply the validation steps with full clean. Django has multiple validation steps for different kinds of validation rules. So we have to remember to do the full clean. And we've seen that validators are really about validating that our data is good before it gets into the database and don't have any impact on data that's already in the database. Let's talk a little bit about tests, and then that will be a good point to switch gears and do some work time to get your hands on code for the things that we've been learning about before we learn more about actually taking our models and serializing them and turning them into JSON. So you all got a little bit of a preview of tests yesterday with the assignment, and I actually have some updates to do with those tests. And you know, we've seen testing before, and we've seen it in the OOP assessment. So hopefully a lot of this should be familiar. Django uses a library called unit test. Which you can dig into and read about right here in the unit test docs. Right, so this is the test library that Django is using. I'll just throw this in the Zoom chat. I do recommend cross-posting this. I do recommend having this open. There's a lot of useful things in here. As you can see here, a test is now a class, and each different test is going to be, excuse me, a method. There's a whole bunch of different kinds of assertions that unit tests can do, and the docs have a very nice list of them. So let's write a couple of these tests, and it should look pretty familiar to the code that you were looking at yesterday. And we're just going to go inside tests py in our Pokemon app to do this. And so Django test is under the hood is using unit test. And there's a little bit more that Django has added, and you can find it in the Django docs as well. We're going to want to use that validation error because we're going to need to write a try catch block to handle it. So let's go ahead and import that now as well. And we're going to need to import our model that we're testing. And as you guys saw earlier, while VS Code doesn't complain if I don't do a relative import here, I don't think Django likes it. Certainly the Django shell didn't like it. So I would just do relative paths with like dot models or dot validators, so on, from importing from the code that we're writing. And the tests are going to be organized into classes. So I'm just going to call this Pokemon test, and we have to import the test case class. And each method is its own test. So let's test that a Pokemon is created. And we have to pass self. Quick question. What does self represent here when I'm using it inside my code? Like if I do, you know, self assert equal false or whatever, what does self represent? What type of object does self represent? Gary, yes, sir.
It's like a point of reference.
Yes, and a point of reference to what? Is it the Pokemon? Is it an instance of the Pokemon model? Is it an instance of something else?
It'd be the instance of the Pokemon test.
Yeah, exactly. Exactly. Self is an instance of the Pokemon test class, right? And so that's when we're writing these tests, that what self represents. And Gary, thank you very much, man.
You're welcome.
And yes, that was awesome. And let's build this out a little bit, right? We're gonna need a Pokemon. So let's go ahead and create it. And of course, our Pokemon is gonna be Pikachu. And its description will be only the awesomest Pokemon. I'm just going to make a nice short description in the interest of time. And we're going to need to create it, right? And we're going to need to save it, and we're going to need to do some validation. So we've created our Pokemon. Now we want to validate, and then we want to save. So we want to do full clean. And then we probably do want to save it to the database. But let's make our test a little more specific. Let's say that like we want to create a Pokemon and we want to test that it's valid, right? So let's say create valid Pokemon instance. So how do I tell if this, what's my code going to do if the Pokemon is invalid? What can the test look for to tell if validation fails? What does full clean do if validation fails? Erica, yes.
It will erase the error that you established before.
Yeah, exactly. And how can I tell my test to look for an error and do something if that error happens? Garrett, yes.
Would that be try and catch?
Exactly. Exactly. In JavaScript, it's try catch. In Python, now that I'm looking at my guide code, I'm reminded it's try except. Same thing. And I know you all have seen this before, right? I'm just asking about it in a different context. And now my test can know, and in fact, we can put this here because that's always going to happen. It's going to be the validation step that maybe throws the error. Now my test will do something if full clean throws a validation error. And the unit test library offers a very useful function, a very useful method, fail, that causes the test to fail. Right, and let's just print the exception message as well. So now if I run this full clean, if it throws a validation error, the exception will catch it and the test will fail. And when you're writing tests, it's always a good idea to start by causing your test to fail first, confirm that your failure case works, and then make it work correctly. It's way easier to write tests that way. And let me hop over to one of my command line spots. I think I'm in the right spot right here. And if we do Python manage.py test, fingers crossed, my test should run. And I've got a failure, which is what I'm expecting. assertion error, self.fail, Django core exceptions, validation exception, name, improper error format, right? So now the real test is, if I make Pikachu valid, does it succeed? And it does. So, you know, if I really wanted to go to town testing my validation function, I could test all the different cases. To be honest, at that point, you might just want to write a test on the validation function itself. But this is a pretty good sanity check. What we can also do is inside here, we can just make sure that this Pokemon exists once it's been created, right? That certainly can't hurt. If I do self.assert is not none, that should also confirm that something else hasn't gone wrong in my model, and that indeed this Pokemon has been created. I don't even necessarily have to save this to the database, to be honest. This test already does all of the checking that I need for my code. And again, we see that the test passes. And I want to check in and see if folks have any questions around this test and the use of the try and accept block and the self-fail. Cody, yes, sir.
Should that be assert is not none? Because I think assert is none would mean it's not there, right?
Yeah, you're totally right. And in fact,
And it
I'm
looks like
kind
a
of
good fail. And
yeah, I apologize. My brain was so on autopilot there. You know, and that's kind of the limitation of tests, right? Like, if we read the test wrong, the test isn't going to help us. At least I wrote it right. Thank you so much, man. You're absolutely right. This failed because indeed Pikachu exists. And I was saying, hey, does this not exist? So let's try assert is not none. Also, if I'm kind of root causing it, right, autocomplete is great, but a little dangerous. Now let's see if we run and we pass. There we go. Thank you so much, man. So let's write one more test, also looking at our Pokemon and validation just for fun and to kind of close the loop on this and reinforce this. Let's test something with, well, we already sort of tested the invalid name format. Let's go ahead and write a test to test specifically the invalid name format. And what I'm really doing here is this test was kind of testing two things: that a Pokemon got created and that my validation was being applied. I'm going to break that into two separate tests so that it's easier for me to kind of see what is causing my failure. So let's go ahead and create another new Pokemon. And we're going to name them something that is obviously not correct. And we'll just give them a description. This is the Pokemon description. Right? And so this is multiple kinds of failure. And again, we need a try catch block. And I don't even care about saving in this test because I know that I'm just interested in the behavior of the full clean and the validation logic. And in fact, what I want to test with this test is test my validator throws an error when it should. Right? So we want the validator to fail. So if we want the validator to fail, do I want to do self fail here? No, because this test, I'm actually kind of testing for the negative case. We are expecting full clean to throw a validation error. We want to test that it does. So I want to assert that this error is thrown. So what I'm going to do here is add an assert true statement, and based off of the error message that we saw before, if I scroll way back up, we see name, improper name format. So I know that my error message should have improper name format somewhere inside that dictionary. And I see that this dictionary has an attribute name. So let's look inside there. And this logic gets a little nested, but we'll talk through it in just a sec. So I want to look at the validation error message and check it to see that it's the right kind of validation error, right? It's not the levels field or anything else that's going wrong, but it's the name. And let's see what I got wrong here, because I think this should have thrown an error. But my guess is I have probably a simple string mistake somewhere. I wonder if I need a period here. Yeah, that fixed it. So that does point out the limitations or just the challenges that go along with testing. String comparisons, as you all have learned, get very exact, very fast. I'm looking inside this dictionary at this property name and asserting that this string exists inside there. And I guess whatever level of exactness that Python is using for that, it needed the full string, right? It's not, when I had that period missing and the string comparison wasn't exact, then that assertion was failing. So if I go back here, I see right here, improper name format, and I added that period, and that was kind of what got me. But so here, now we're testing that this validator does behave properly. And so if we were to fully test out that validation function, we might have a class just for it, and we might have a test for each case, right? Because the validator is looking for that it starts with a capital letter and that there are no like numbers or other characters in there. So if we really wanted to absolutely test this validation function, we might have a test class just for that and have a number of them to test each specific case. And then I might want to maybe make my error message more specific to help me with those tests. But you can see here the basic approach of like testing for the negative case and asserting true here and looking for the error here. And you can kind of see again the value of this try except. Sorry. Cody, yes, sir.
Yeah, at the bottom where it shows the test that passed, usually you just see the two dots in a row. But it's showing one dot. And what's causing that to print out? See how it says like, see what I mean?
Question.
Usually it's just like two dots in one line that you see. So what's causing that extra print statement?
So each of these is coming from the exception. We've got this one on line 31 where it gets printed. over here, this exception isn't getting thrown. It does appear maybe it's trying to print something. I'm not certain. Murad, yes, sir.
Yeah, in test 2, I didn't understand the last line. Why you assert at the end? That should be test self assert true, right?
Correct.
That should be inside the try.
No.
I didn't understand it.
Yeah. So for test 2, we know this name is invalid. We know when we run full clean, it will throw a validation error. We are expecting it to, because what we want to test is that our validator correctly identifies an error. So we are expecting this error to be thrown, and I want to assert that it's true that this validation error does get thrown.
So that's test for the test?
Yeah, exactly. And Cody, I'm honestly not sure. I wouldn't worry about it too much with this. You know, there's a lot of stuff that gets kind of printed with the test library. My guess is if we comment this out, that might go away. No, I don't know. But considering that this is not like key test output, right? It's not part of a test failure or success message. I'm not sure. It's possible there's maybe a print statement hiding somewhere in the code. I'm honestly not sure what's causing it.
I think it's line 31, comment out.
Well, line 31 is definitely printing out this first one. I'm not sure about the second one. And it looks like just the way that Django and unit test decided to work is it prints this 2 dots at the end, and if we have any print statements, it goes in between the 2 dots. So again, there's no real rhyme or reason or meaning there to that part of the output of the test.
Thank you. Yeah, that was good.
Yeah, for sure. And good call on commenting out line 31 and seeing the change. Okay, awesome. I know I ran a bit long, folks. I do apologize. Because I know that ate into our work time a bit. I think we can at least start to get our hands on stuff. We're going to continue to build out the school API. And so the first part of it is just to extend the student model and start using some validators. And there is some custom regex that we want you to add. And then we also want you to use some of the built-in validators as well. As a friendly reminder, this assignment has all the code you already need to get started in it, right? If you want to build on your code from yesterday, you can, but everything you need is here. As it's 10:43 right now, why don't we take until what, maybe 11:15 Central to take a break and work on this and get a little bit of hands-on time, and then we can dive into the second part of the lesson on serializers, because that part is important and I don't want to shortchange that too much. Does that sound good to folks? Okay, awesome. Thank you for bearing with me. Let me go ahead and stop the recording, and then we can get our hands on writing some code. So we've spent a lot of time talking about models and validation, right? And we've kind of seen this process of, I drew these boxes here. The boxes don't represent much, but they're a good visual indicator. We create a model instance. We've learned that we need to validate it with full clean, and then we need to save to the database with .save. Right, and then maybe, you know, like I want to use the Django shell, or I'm writing some Django code. And maybe what we end up doing is, you know, we get the model from the database too. Right, you know, we're going to get model info from DB with something like right, just as a simple example of a query. And so we've seen there's this process of data going in and going through this validation process. And then we also grab the data and do stuff with it. And to kind of hop back over to this other diagram from yesterday, the piece that we haven't really gotten to yet, you know, everything we've been doing is in this part, right? With the database talking to Django. But we want Django to be able to send JSON over the internet to the browser or any other client application. And we want the browser, if I'm maybe creating a Pokemon, to be able to send information to Django. So there's a step that's missing over here. Of what's called serializing. Or deserializing. Right, where maybe I have, and let me make this a bit bigger. Maybe the browser is sending me, you know, I hope that's a Pokemon name, E or something like that, and they're, you know, level 4. And I want to create a new Pokemon model instance and save it to the database. Or over here, you know, maybe we're returning to the browser information about Pikachu. And it'd be really nice if we can use and leverage all this object-oriented code in Django to do this. So this is called serialization. And I like this, just this first Wikipedia sentence. Serialization is transforming a data structure or an object state into a format that can be stored or transmitted over a network, right? And for us, that means turning an object into JSON or turning JSON into an object. And what we're going to use to help us with that is a framework called Django Rest Framework. That's very powerful and very good at doing this. Now, Django does have some built-in serializers, and we can see them in action, and we'll take a look at that in a minute. But Django Rest Framework does a lot of stuff really nicely, and we want our serializers to be able to handle complex data types. We want to be able to apply all of this cool validation. We want the serializers to be aware of relationships between models, right? So let's take a look at what Django gives us for serialization, and then we'll kind of see how Django Rest Framework gives us stuff that is frankly nicer. So I'm going to go ahead and I'm going to exit this real quick and open it back up again just to make sure that there's not, like, you know, any changes we made that I'm forgetting. And let me do a clear so we have a nice clean console to work with. And I am just going to kind of go through this, and we're going to kind of go through this together. I don't suggest coding along. I'm using Shell Plus, which I'll kind of share the steps for later. So this step has already been done for me, but just to repeat it there, for those of you just using Django Shell, you want to do that. Let me get all the Pokemon. Oh, and that was way too much auto completion. And let me just print all the Pokemon, and let's just see what we have here. Right, and we have Bulbasaur, and we have Squirtle, and we have Pikachu. Let's make Blastoise just so we have Blastoise, just so I can kind of be in line with what we have here. And now that we have our validation, I'll get an error if I don't do that. And we'll do Blastoise full clean. And we'll do Blastoise.save. And just for fun, let's grab all the Pokemon again. And let's go ahead and print them. And now we've got Blastoise in there, and it looks like they're the fourth person. So let's just grab Blastoise from our database. It looks like that's actually Pikachu. And now we've got Blastoise. Right. And in fact, I could have done this Pokemon objects.get query as well to get Blastoise. So we can query our database. I've just been so used to doing it the other way that I forgot to do that here. But this is actually the better way to do this moving forward. Let's see what this did not like. Pokemon matching query does not exist. I wonder, I'm not going to go down this road right now. I'm not sure what's throwing this error. Oh, Earl John, yes, sir.
I think it's just the spelling error. It says the Pokemon Blastoise instead of Blastoise. So there's no I in the Blastoise.
Oh, in the name that I saved?
Yes.
Oh my. Thank you so much.
Yep.
Yeah, you're totally right. All right, well, let's go ahead and fix that. Blastoise name equals Blastoise. Blastoise full clean. Blastoise save. Perfect. Thank you so much, man. That's kind of problem to have. That's an easy solution. So we're going to import from the Django core serializer library. And just to take a quick brief look at this in the docs, you can see that there's a whole section on this, on talking about how to do this and all of these different things. We're going to be using Django Rest Framework pretty quickly for this, so I don't recommend spending too much time on this. A little bit of time is good, but not that much. So again, with Django Shell, you'll have to add this import statement manually. So, and let's see what happens here now when we use this. And let me go ahead and clear the terminal so we have some room. Right, we have Blastoise. Let's do Blastoise serialized, and we can use this serialized function that Django gives us. And the first argument is how we want to serialize the data. And the second argument is what we want to serialize. Except I get an error. And if I look all the way down, I see the error is type error. Pokemon object is not iterable. So the serializer isn't just for a single instance of a model for one object. It might also be for a list of objects or a list of dictionaries. So whenever we pass our actual stuff into a serializer, our model instances, we need to wrap it in a list, something that's iterable. And now that doesn't throw an error. And now we can do some stuff with this. And we see that what we have here is a bunch of text, in fact. And it's a JSON array with some JSON objects in it that have Blastoise, along with some additional information. And it looks pretty much exactly what we see in the fixture file, in fact, right? And to reiterate, this is text. This is not a dictionary. I can't do this. This is not going to work for me. This is going to throw an error. Right, string object has no attribute get. Because right now, this is just text, right? We've serialized our object into JSON. And so now we need to deserialize it back, right? If we want to do that. And we can do that with the built-in Python JSON library, which I'll just import here. And I apologize, I'm starting to run out of room in the console. So I think I'll just go ahead and clear it. And if I use JSON loads from the built-in Python JSON library, and I pass in this text, this string that we know is in the JSON format, and I managed to not misspell the variable name. Now, this should be a dictionary. And the autocomplete is a little too smart. My apologies, we want JSON Blastoise. All right, and now we can get the primary key, we can get fields, and off of fields, we can get name. So, right, just using the very basic tools that we're familiar with JSON and a little help from Django, we've seen how we can, to go back to this diagram, serialize and deserialize our data. But this isn't, it's a little bit of a pain. It's not very friendly, and Django Rest Framework is going to make our life a lot easier in doing this. Where we're going to end up with Django Rest Framework is we're going to be able to create a serializer class and give it some rules around the fields, and then work with this serializer object that's extremely powerful. And we'll get there in a couple minutes. I just want to give a little bit of a preview of where we're heading. So let's see how to install and use Django Rest Framework. And before diving into that, I do want to check in and see if folks have any questions or stuff that might be good to review on this thus far. And does everyone feel good about sort of the big picture of serializers and why they're important? Okay, awesome. So I am going to go ahead and exit the Python shell since we're going to be doing some installing of things. Django Rest Framework is pretty friendly to install. I just have to make sure my virtual environment for my project is activated, and I can run pip install Django Rest Framework. We're going to be using Django Rest Framework for a whole lot of things. In fact, it's not just serializers. It offers a lot of very nice sort of enhancements of Django for authentication, for a nicer way when we start writing like routes and views and stuff like that. And it's a pretty popular project. So there's a lot of things actually that Django Rest Framework gives us. We're just starting off with serializers. Like most things with Django, once I install something, I have to add it in settings PY. And in this case, we have to add it under installed apps. So I'm just going to add it right here. And the name of it is actually just Rest Framework, which is in the Django Rest Framework docs. So we pip install Django Rest Framework, but for installed apps, we just add Rest Framework. And then that should really be all I need. As a quick sanity check, I am going to run the Django server. Our server doesn't do anything, but I just want to make sure I don't have a typo in settings PY or I didn't do anything silly. I see Django running. I know I didn't do anything silly. So now we can kind of get on with the show. Great, and now Django Rest Framework is installed. Let's see how to actually create a serializer class using Django Rest Framework. And let me go ahead and close out settings PY and all these things we don't need. The model, I think, will be useful. We might come back to that. So just like our validator, we created inside the Django app, right? And the idea is everything Pokemon related is inside here. And as our app gets more complex, maybe if there's user accounts, that becomes a different Django app. But all the Pokemon stuff is here inside the Pokemon app, Django app. We're going to do that as well for serializers. And I totally misspelled that. So let's just go ahead and rename it right now. And we're going to need to import a couple things. From Django Rest Framework, we need to import the serializers. Some sort of class or like a dictionary. It's a class holding a bunch of other classes. And we're going to need to import our Pokemon model. And we're going to create a class and we're going to name it Pokemon Serializer. And this is a good naming convention. Start with your model name followed by serializer. And this needs to inherit from the model serializer class that we get from Django Rest Framework. And just to take a quick look at that, if we hop over here, if Django Rest Framework would, there we go. So if you want to, you can dig through the Django model serializer docs. This isn't taking me to the spot that I wanted. I thought it would take me to the model serializer code, which would have made a bit more sense. There we go. So the Django Rest Framework docs these are very good. And I think they're probably better than the Django docs. And you can see that there's a very solid breakdown of Django Rest Framework's model serializer class. One thing that's important to note is it inherits from this serializer class, which I believe might be coming from Django. Model serializer will automatically generate fields for us based on the model. It can automatically generate some validators for the serializer based on our model validators. It includes create and update. It includes simple implementations of methods for saving to the database. And we can see that making a model serializer is a little funny, but not too crazy. We're creating a class inside of a class meta. We give the name of the model, and then we give the model fields that we care about. So this is kind of new, but the rest of this is actually pretty intuitive and familiar. And let's go ahead and do this now for our Pokemon serializer. So here we're telling our serializer what model to use. And it's going to look at the model's fields and the validators on those fields. Here we have to specify the fields we want the serializer to return. We might not want our serializer to return every single field. We might want some fields to be private. Maybe we don't want to share the ID fields, or just depending on how we're designing our application, we have that level of control. Right, and just to take a quick look and comparison, let me close this out and let's do a split. And over here we see our Pokemon model, right? With the name field, the level field, these other fields. And in fact, we're not worrying about date encountered, date captured, description or captured. Right now, all we're doing is ID, name, and level. So you can sort of hopefully visually see sort of the relationship that you can build between a serializer for a model and the fields on the model itself. And now I am just going to, I'll leave this code up here as a reference, but we're going to use this Pokemon serializer that we just created, and we're going to play around with it like we just did and just see how flexible this is. We'll see how validation gets applied that we've created, and the other nice things that it gives us. So let me bring the terminal up here. And I just want to pause and check in and see if folks have any questions or anything that might be good to review, because this is a good pause check-in point. We feeling pretty good about this? Or kind of like our brains are done, this is a lot of stuff?
So far, so good.
Okay, awesome. And being somewhere in the middle is totally okay. The good news is once you start writing one or two serializers, like there's a very common pattern to follow. Big picture, remember the serializer's job is to turn JSON into objects and objects into JSON. And we're just adding some nice extra stuff along the way to help us with that. So I'm going to import in the shell my Pokemon model, so we have that to play with. I'm going to import the Pokemon serializer that we just created. And note how the import path is from the appname.serializers. And now let's get the Pokemon with ID of 1, which is hopefully Pikachu. So this get queries the database based on whatever field we're asking it to look for. And let's see and confirm we got the right thing. Note that this didn't return a list. It just returned the one thing. .get is designed to get one thing. It doesn't send back a list. If there's multiple results, I think it just returns the first one. Now let's create a serializer for Pikachu using our serializer class. And I think the hardest part of this is not misspelling serializer. So this is kind of cool, right? I can print this out. And we see that it's an instance of the Pokemon serializer class. And we've got the ID, we've got the name, we've got the level. We only have the fields we care about. The serializer has ignored the other ones. And we see this is in the dictionary. It's not text. This is actually an instance of an object, right? I can do Pikachu serializer dot name. I should be able to do Pikachu serializer dot name. What did I do wrong here? Oh, I apologize. I may have gotten this completely confused. Let's try it this way. Got it. Okay, I apologize, folks. I totally jumped the gun there. Pikachu, the model instance, has that property name. Our Pokemon serializer object doesn't have those attributes, but as you can see, it does have, essentially, I believe it's a dictionary. I'm curious if we do get ID. Yeah, so it's not quite a dictionary, right? Because it's not actually a Python dictionary, but it's something very similar. We could look in the Django docs on the model serializer class, and it would tell us. Yeah, I'm not going to dig into this too much because this inherits from the serializer class, which is itself a type field, and it inherits from other things. I'll kind of, I think, poke around in here to make sure I can give a better answer. But I think the key thing is we have like a dictionary-like object. And there are a couple things in Django that are like this, where once we have this serializer to access individual properties, we have to use this this bracket notation. And we see that it doesn't actually return the value. It returns an instance of this, like an object of the field class, so that the serializer is doing a lot of stuff under the hood. And in fact, the most interesting part of this is if we do Pikachu underscore serialized.data, let me make sure I get that name right. Pikachu serializer, I'm so sorry, .data. We see that that returns something that looks an awful lot like a Python dictionary, right? I think that is a Python dictionary. It's either that or a string. Yeah, and indeed that is a dictionary. It was a little hard for me to tell from the output here. So we have that data saved as a dictionary, but the serializer doesn't necessarily want us to interact with it directly and has some sort of like intermediate things that we can do with it. And what we'll see in a little bit is that we actually use the serializer to do all sorts of stuff. Because what we eventually want to do is we want to output this serialized stuff as JSON, right? And in fact, let's take a look at kind of how to do that right now. And I think I want to just scroll through here. And I think, in fact, what we can just do is we can either use Django Rest Frameworks JSON renderer, or we could even use like the JavaScript JSON renderer. We have a couple different options of how to do this. And in fact, let's take a look at this JSON renderer. And I just want to make sure that I'm not adding in any complexity that we don't want. So Django Rest Framework has a JSON rendering function. It turns basically a dictionary into JSON using a particular style of encoding. And since we're using Django Rest Framework for all these other things, we probably want to keep using Django Rest Framework for all this stuff. So I think, in fact, kind of like following this guide here is the way to go with this. And if I do JSON renderer render Pikachu serializer data, we get some JSON outputted. Right, so now that I have this serializer, the serializer's job is to get me the thing as a dictionary, and then we use a different tool. In this case, the Django Rest Frameworks JSON renderer to render this into JSON as an output. And we'll see kind of in a minute when we go in the other direction that there's a lot of validation that the serializer lets us apply. It lets us do a lot of nice things when we have data coming on the way in. We can also do some nice stuff like if I have all the Pokemon, Django's serializer can handle a query set or something that's iterable, this list of all of our Pokemon. So I can do all Poke serializer equals Pokemon serializer. So this serializer that we wrote isn't just for an individual Pokemon, it's also for a list of them, essentially, a query set in Django's terms. However, we have to add this argument many equals true. When we're calling the serializer constructor, we have to tell it that it's getting many different things. And now we see that we have this Pokemon serializer query set that we can access all of these different things. And if I do .data, I see that we have this dictionary, right? And this is where the flexibility and the power of the serializer starts to come into play, and why it's kind of nice in some ways that the JSON rendering step is a little separate. You know, and now if I want to do, you know, JSON all Poke equals, let's do JSON renderer render all Poke serializer.data. And now I have a whole bunch of JSON with all of my Pokemon. So now I can send that list back, right? And I've done this in about 3 lines of code, right? And leveraging all of these things that we already have. And once we start to get into relationships between different models, the serializer will handle that as well. And now I can very nicely and easily send JSON from my Django API to React or anything else. And I just want to pause it and see if folks have any questions. Cool. So this bit is important, that you need to add many is true when you're using the serializer with a query set result. It's in the curriculum lesson doc. I'm just going to post it in the Zoom chat. And if someone wants to maybe dump it in X-ray questions as well, that would be awesome. I think that's probably the easiest thing to forget. Again, I think the Django Rest Framework docs are your friend. I know there's a lot of stuff here, but they actually lay it out very, very nicely. As you can see going through it, and I use it as a reference all the time. So the last bit I want to touch on is going in the other direction, is once we have some JavaScript, let's actually turn it into a model instance and run our validators and save it. So let's say that I've gotten some JavaScript. I've used, whether it's Python's built-in JSON method or Django Rest Frameworks, I've turned my JSON, excuse me, into a dictionary. Right, and in fact, I'm going to remind myself how to go in the other direction here with this. I think it's just JSON.loads. Does that sound right to folks? JSON loads. Yeah, I don't have that quite right. I apologize. I can't remember the Python step off the top of my head. Can anyone maybe remind me, like, what's an easy way to turn some text that's JSON into a dictionary in Python? Because we might as well close this loop. And I thought I was there. Brandon.
Did you import JSON?
I thought I imported JSON. I wonder if I just got the format wrong. Because I have JSON.
It is JSON load.
Oh, I wonder if I just used the wrong method name here. No, it looks like something's going wrong with my import. I'm not gonna, I apologize. I don't want to go down too much of a tangent, folks. This is a solved problem. Brandon, thank you though. We're not going to worry about the step of converting the JSON text into the Python dictionary. Once we have the dictionary, let's put it in the serializer and see how to do that and see what happens. So once I have a dictionary with my JSON data, I can use the serializer again. But when I pass it in, I need to pass it in as an argument to the data argument. So when I'm going in the other direction, I need to do it like this. And then what this lets me do, we see something very similar to what we saw before. And what we've always had with this serializer class is an isValid method, where we can check the validity of our data. So let's say, let's make a new EV where the name is something that's totally not right. It's going to be like lowercase e and there's going to be a 3 and like a v and some e's, and the level is -12. So I have that serialized, but now if I run that isValid, we get false, right? And under the hood, isValid is basically running full clean for us. And so this is the value of the serializer, is we can check for validity and do something about it, right? And let me go back to the let's make this a good version of EV, because I also want to show us this save step. Once our serializer has data and we've validated it, we can run save. And now we have a Pokemon, and it's saved to the database. So ser EV is still our serializer, but if I go into pSQL here, EV's here in the database. And over here, if I do, EV, we'll just do EV Poke to distinguish. Pokemon objects get name equals EV. We get our Pokemon, right? So now we can kind of see the Django Rest Framework serializer with data on the way out, right? We have our model, we want to turn it into JSON, and data on the way in. we have JSON, it gets turned into a dictionary, we want to validate it, and the serializer uses all our model validation rules, and then we can save it to the database. So that's the big plus of Django serializers. So I'm curious what's on people's minds when it comes to the serialization, the concepts or the application. Eric, yes, sir.
Does your serializer force you to use the is valid method, or is it like full clean where if you forget it, you kind of just miss that step?
That's a great question. I think I'm actually not 100%. Let's actually look at the docs and confirm. Or even better, we can test it out. I think it forces us to use is valid, or rather we have to do that manually. But it's always good to test and run it. And indeed, here in the docs, it does say when deserializing data, you always need to call is valid before attempting to access the validated data or save an object. Let's see if it throws an error or not. I think that's actually a good one. Let me go ahead and clear this. What's another Pokemon that we can use to do this with that we don't have in there yet?
Charizard.
Charizard, perfect, thank you. Right, so Charizard serialize. Let's make Charizard all wrong. Right, the name is wrong in multiple ways. The level is -12. Let's see what happens if we save Charizard. So this is actually really nice behavior of Django Rest Frameworks. Great question, Eric. And it was kind of what it was saying in the docs. I wasn't totally sure. And when in doubt, I think running the code is always the best answer. We have to call is valid before calling save. And under the hood, what Django Rest Framework is doing is the serializer has like an errors list or something like that, and probably some sort of Boolean to check if is valid has been called or not. So it knows that we haven't called is valid yet. So it also it requires us to do that manually, because there's a lot of different ways that you might construct these objects. Sometimes when we get user input, we might get multiple JSON objects that we have to combine or something like that. So there's often times where we need that level of control. And so this is telling us that this is false. And in fact, let's see about, let me actually check the docs, because I know there's got to be a way for us to see the errors. And indeed, if we just do .errors, it should give us either a dictionary or a list of all the errors. And note that these error detail messages come straight from our validators, right? So this errors dictionary is empty until we call it is valid. And then if there are errors, they're put in here and we can see them. And so this is what we could use in our code to either give input back to the user, or maybe in our tests, or if we could like look at the code to do something with it to see what exactly went wrong. Yeah, great question, Eric. So just to reiterate, if we try to run save without running is valid, we'll get an error. Django Rest Framework won't let us do that. When we run is valid, if is valid is false, we can look at the errors dictionary on the serializer and see what went wrong, right? And this is great for writing tests. You know, this is why the serializer class is kind of awesome, because it lets you do all these very nice things with it. What else is on people's minds? What other questions do folks have around serializers, Django Rest Framework, how to use them. What's on people's minds? Are we feeling pretty good about for the assignment for this afternoon, writing some serializers and putting them into practice? Yes, no, maybe. Okay, awesome. Let me just do a quick kind of overview of the second assignment, and then we can wrap up. So today is a pair programming day. I am going to be sending out pairs over lunch. If you need to request not pairing, you do need to message me. And obviously, if it's like a legitimate schedule conflict, like I have to go to the doctor or I have to pick up my kid from school, that is totally fine, and I'll say yes, but I still need to know. If it's something else, you need to ask and kind of get the thumbs up from me, because the pairing is important. So we have two assignments here. Again, since each of these has all the code that you need, I think just working off of the existing code to add on the next part is useful. As a pair, you probably do want to finish the school API part 1 together, so you may want to just pick one person's project. But then for the next step, you can do it together. So here, we're just very straightforwardly adding on top of what we've already done. We're adding a serializer, right? And note that we're going to be adding a serializer for an individual student, and also a student serializer probably that we're going to be using for a list of students, because we maybe want to show some different information. The validations exercise goes more in depth into writing some validators. It gives you some rules that you have to follow. Some records are incomplete, and you'll want to explore the Django docs to get into this. This is a really good one to do. I do think you should prioritize these school API assignments. I think it's really important to be writing code and keeping up on these. Otherwise, frankly, it's just, you're not going to be able to internalize the stuff that we're learning. So that's the plan. Let me go ahead and stop the recording, and we'll just kind of check the schedule, and then we can break for lunch.